morning, everyone. Good morning. So, what is the last subtopic we have done? Hello, what is the last subtopic we have done? Yes. Capacitance. Did you write anything under that? No. Fine. Did I speak anything about your results? Yes. Are you happy with what you have done? Are you home? Are you happy with your results? So let's speak about physics. I have no time to speak about the others. Are you happy with your results? Yes. Some of your people didn't send me the results. I told you to send me a message on WhatsApp. I think I got some of you, yes. Did you? Marks? Yeah, fine. Now guys, let's say I'll tell you an interesting fact about how these results work. Okay. Now let's say there are two students. Tell me two names. No. Not the students here. Just tell me some random name. Okay. P and Q. One student is P, the other student is Q. Let's say this is AS levels, this is A2 levels. Right? Now for AS levels, let's say, listen up. Guys, you understand now this is given out of 300. So 240 is 80%. Have you understood that? So if you have got a 240, you call yourself, you have got an A. If you have got 239, you call yourself, you have got a B. Correct? So if you have got 270, that means 90%. Right? For AS levels, if you get 270, what does that mean? Have you got an A star or A? There's nothing called A star. Fine. Listen, still it's an A. Listen, how does this A star work overall? Now let's say P has got, P is an exceptionally very good student. He has got 200 and, okay, I'll take 300 for AS levels. 300. Q is an average student who has got 230 for AS levels. Okay. For A2 levels, P is getting 265 for A2 levels. P was a bit overconfident, he took A2 easy and he got 265. Q worked really hard for A2 levels and Q got 270. Okay. Shall we check their total marks out of 600? For P it is 565. For Q it is 500. Okay. What do you think their overall results is? P is getting it? P is getting it? A star. Q is getting it? You're wrong. Q is getting an A star. P is getting an A. Did you know that? Did you know that? Okay, listen. The criteria of getting an A star is this. Listen to me carefully. Overall, your grade has to be A. That means overall your grade to be A. Out of 600, your total marks has to be more than 480. Out of 600, 480 is 80%. So if your overall marks is more than 80%, yes, you are getting an A. Overall, it has to be above an A. For A2 levels, it has to be above 90%. Do you understand what I'm saying? Overall, it has to be above 480, above 80%. For A2 levels, it has to be above 90%. So even though B has got 565 and Q has got 500, it depends a lot on your performance in A2 levels. Do you understand what I'm saying? So whether you have got 230 for AS levels, or whether you have got 220 for AS levels, or whether you have got 290 for AS levels, it doesn't matter. If you want to get an A star, for A2 levels, you have to cross that 270. Am I talking too much numbers? Okay, summary is, if you want to get an overall A star, your A2 has to be above 90%, overall has to be above 80%. Understood? Right, I hope you understand. If you don't understand this, anyway, you don't deserve to get an A star, simple. Right, guys, get back to work. And well done, those who have done it well. Very good, happy for you. And your hard work has paid eventually, right? And speaking about physics, you would have noticed that, I mean, relatively comparing to other subjects, you feel like physics marks is low, and that is how it is, right? So if you think your physics marks is low, but to be very honest, in my opinion, the B that you have got for physics, for me, more valuable than the A that you have got for the other subjects. So that is how I look at it. So those who know it, you know it, right? Fine. Anyway, guys, if you have got a B, my point is still you have the chance of getting an A star. Still you have the chance, I mean, obviously you have the chance of getting an A as well. I'm saying, if you have got a B, you have an equal chance of getting an A star as much as a student who has got an A star already having. Okay, whether you have got 235 or if you're the person who is seated next to you has got 290, still both of you have equal chances of getting an A star for overall results. All you need to do is somehow cross that 270 for A2 levels. So those who have got really low results, some of you have already spoken to me. If you are not in a situation to make a decision about what you want to do next, always you're welcome. You can drop me a message and reserve a time and come and talk to me, right? I can help you with whatever the way I can. If you want any advices, yes, when I'm free, you can come and talk to me, okay? Especially those who have got really low results, you might have to repeat certain units depending on what you're looking to do. Okay. And the common question that I get to, I mean, a lot of people ask is about repeating these exams in before next major, like a unit in January or something. Personally, I don't recommend that at all, right? The reason is, guys, if you have done AS levels and if you have already found it challenging, trust me, the A2 levels will be a bit more challenging than that, right? And also on top of that, if you're going to allocate your time for another exam during this A2 session, your focus will be on that, okay? Without you realizing, whatever said and done, you will be more focusing on that. You will not realize that you are missing on your A2 work, right? It's a very stupid thing to do in my point of view. It's up to you to make a decision. So I will not recommend it at all. If you are by any chance repeating any units, just straight away, keep it for next major, okay? Don't make decisions in a rush. Now, if you have especially got low results, your state of mind is not normal, okay? You have already started panicking, you're worried, you're sad, you get to hear from other people, your mental position is not normal. So whatever the decision that you're making at this point may not be the right decision, okay? This is where you need some advice from people who already know it. Get the opinion of people who will genuinely wish you good. Get advice from those people. And my opinion is, if you are repeating anything, just keep it for next major. Okay, take your time. Don't rush. Don't just do it for the sake of doing it. Realize your mistakes, where you have gone wrong. See whether you have spent enough time for studies. Change your gears. Take studies more seriously. I have been always telling from day one. whether you like it or not, you have chosen science subjects, not commerce subjects. So commerce students, guys, you can see who just work for the last few months, getting A's and A stars. That is how it is. I'm pretty sure if most of you people had chosen commerce, with the amount of work that you had done, you will end up getting A stars. Okay, that is how it is. So, but you have chosen to do science. Some of you people are doing very challenging subjects. Some are doing further maths, okay, and physics, and 4 subjects, 5 subjects. Some people are doing bio and chemistry and further maths and that. So the workload on you is very high. So before you made that call, you should have known that you have to work a lot. So your studies has to be your priority and nothing else, right? Don't waste your money on exams. Take it very seriously and do it well. Right, guys, capacitors. Write down the subtopic. Capacitance of a parallel plate capacitor. Capacitance of a parallel plate capacitor. Okay, right. So guys, a capacitor will look like this. Draw this diagram. This is how we draw a capacitor. Okay.
So is that an I or an N capacity? Yes.
Capacitance. I think it which is I or which I.
Nothing.
Right. Guys, what's a capacitor? What is a capacitor? Any idea? It's a device which stores electrical charges on its plates. Okay, stores electrical charges on its plates. So overall, it stores electrical energy. A capacitor is something which stores electrical energy in it. Okay, right. So if a capacitor has 2 plates, a positive plate and a negative plate. In the positive plate, let's say if it is having a charge of plus Q, the negative plate, the charge will be minus Q. And let's consider the potential difference between the plates to be V. So what is defined as capacitance is the ratio of charge to potential. C equals Q over V. Okay. Right under that. Capacitance.
Chance to draw.
Didn't you draw it? I already told you to draw, right? The capacitance of a capacitor is equal to the ratio capacitance of a capacitor is equal to the ratio between the charge stored on one plate and potential difference between the plates. So guys, take it down as an equation. C is equal to Q over V. C is the capacitance. Q is the charge stored on one plate. V is the potential difference between the plates. That's your book. Book, where's the book? Right. Guys, what is the unit of charge? coulombs. V, moles or joules per coulomb. What is C? Unit of C. C has a separate unit. Have you heard of farads? Farads, no? Capacitance is measured in farads. Farads, right? Unit of capacitance is farads, denoted by capital F. Yeah, tell me. Right. Right on the next subtopic. Capacitance of a spherical conductor. Capacitance of a spherical conductor. Right. Guys, let's say there is a sphere. Okay. A spherical conductor which shows a charge Q on its surface. And let's say the electric potential at the surface is V. The electric potential at the surface is V. Then its capacitance is given by C equals Q over V once again. Now this time, Q is the charge stored on the sphere. V is the potential at the surface. Take it out. E is the potential at the surface. Set it up. Right. So guys, capacitance of a spherical conductor is given by Q over V, where Q is a charge stored on the capacitor, on the sphere, and V is a potential at the surface. Right. Right on a question. A parallel plate capacitor parallel plate capacitor has a charge of 30 millicoulombs. 30 millicoulombs, MC, simple MC. Simple M, capital C. A parallel plate capacitor has a charge of 30 millicoulombs. Stored on its plate. Stored on its plate. And the PD between the plates is 1.2 volts. 1.2 volts, full stop. Calculate the capacitance of the capacitor. Calculate the capacitance of the capacitor. Right, guys, C will be equal to Q over V. So the charge stored on one plate is 30 millicoulombs, which is 30 into 10 to the power minus 3 to convert millicoulombs to coulombs. Over the potential difference is 1.2. Correct. 30 divided by 1.2 is? Final answer is 0.025 farads. Correct. The next one. A capacitor has a capacitance of 200 microfarads. Guys, micro is 10 to the minus 6. A capacitor has the capacitance of 200 microfarads. Full stop. Calculate the charge stored on a plate. Calculate the charge stored on a plate when the PD between the plates is 15 volts. When the PD between the plates is 15 volts. Okay. Yes. Right. What is the answer, guys? So once again, C equals Q over V. So which means Q equals CV. So C is 200 into 10 to the power minus 6 into V is 15, which will be 0.003 coulombs or 3 millicoulombs. Have you got this answer? Right. Question, the next one. Write down another one. A capacitor has a capacitance of 20 millifarads. A capacitor has a capacitance of 20 millifarads. Full stop.
So can we go back for 1 second, please? Thanks.
A capacitor has a capacitance of 20 millifarads. Full stop. The maximum PD that can be applied, between the plates is 30 volts. 30 volts. Full stop. Calculate the maximum charge. Calculate the maximum charge. that can be stored on a plate. Can you?
Can you show the answer or the before question for a minute? Okay.
Is that the answer?
0.6.
0.6 coulombs. Q equals CP. C is 20 to 10 to the power minus 3. B is 30. That is 0.6 coulombs. Okay. Right. Does anyone know to get the tube? Right. Let's write down the next topic. There's a question for homework. Which one? Only that one. Right. Okay. Write down the next subtopic. Charge versus PD graph. Charge versus PD graph for a capacitor. Charge versus PD graphs for a capacitor. Now, guys, Q equals CV. Okay. C is a constant. Listen to me. Don't try this. Now, guys, if we take a capacitor, okay. Let's say this capacitor is uncharged. Then I go connect this with a battery in series with a switch. And the moment I close this switch, the battery will release the charge stored in it. It will release a current. And this capacitor gets charged. Okay. Now when the capacitor is getting charged, the charge stored on the capacitor will increase. When the charge stored on the capacitor is increasing, potential difference across that will also increase. What do you think about its capacitance? Will it change? C equals Q over V. Will the capacitance change? No. Guys, tell me what is capacity? Forget about physics. In real world, what do you mean?
Maximum amount something can hold.
your capacity. This is my capacity. I can't go beyond this. No, the ability sort of thing capacity means. So for a capacitor, the capacity means it has a capacity up to which it can store charge. It can't go beyond that. So that capacity for a capacitor, that capacitance of a capacitor is a constant. It doesn't change. Okay. For a given capacitor, the capacitance is constant. So the capacitance of a capacitor depends on three factors. One is the size of the plate. Now, parallel plate capacitor means there are two plates. On the plates only you are storing the charge. If I draw a diagram, this is one plate, this is another plate. So this is a capacitor. Okay. On these plates only we are storing the charge.
So the whole thing is a capacitor.
The whole thing is what we call the capacitor. So how can we store more charge? Definitely by making the plates bigger. Okay. Then another thing that we can do to increase their capacitance is by bringing the plates closer. Okay. And the other thing that we can do is the medium in between. There is something called the permittivity of that medium. By using a medium which has a higher permittivity. What is the word? Permittivity. Okay. By changing basically the medium, you can store more charge. So those are the factors which will affect the capacitance of a capacitor, not the charge and potential difference. By increasing the charge or decreasing the charge, or by increasing the voltage or decreasing the voltage, you can't change the capacitance of a capacitor.
So how about thickness of plate?
Not really. It doesn't take into account for the capacitance. Right. Anyway, guys, my point is, for a given capacitor, C is a constant. So C is a constant means Q is directly proportional to V. So Q is directly proportional to V means it will be a straight line passing through the origin with a constant gradient. So for a capacitor, the charge versus voltage graph is straight line with a positive gradient. Okay, take it down. Okay. Done. Right. Let's write on the next subtopic. Energy stored in a capacitor. Energy stored in a capacitor. Right. Guys, let's take a capacitor which has a charge of Q stored on it, and the potential difference between the plates is V, and its capacitance is C. Then the energy stored in the capacitor is given by E equals half VQ. Half VQ. Take it out. Okay. energy stored is equal to half V Q. But we can come up with two more equations. Since guys, we know that Q is equal to CV. By replacing the Q with the CV,
EC square, half EC.
we can come up with E equals half CV square V into CV. Or we can replace the V with this V, we can replace with Q over C and come up with another equation. E equals half Q square over C. These are two more equations. For the energy stored in a capacitor. Done. Right, write down a question. Before that, make a note. Guys, Q versus V. Q versus V graph, we already know. This is a graph, right? Listen. Listen. Guys, let's say when the potential difference is V, the Q stored is Q. Then the area under this graph is half V Q, right? It's a triangle, half into base into height. This length is V, this length is Q. So that is half VQ. Okay. That is exactly the energy stored equation for a capacitor. So guys, which means for a capacitor, if you have the Q versus V graph, area under the graph gives you what? The energy stored in it. Make a note on that. The area under the graph, the area under the graph, the area under the graph of a Q versus V graph. Okay, right. Write in a question. 20 coulomb of charge. Question one.
So can you go back to the okay, sir.
A 20 coulomb of charge. A 20 coulomb of charge is stored in a capacitor. Is stored in a capacitor. When the PD across the plates is 12 volts. When the PD across the plates is 12 volts. Full stop. Calculate the energy stored. It's a matter of substitution. The answer. So it's just half VQ, right? So half VQ, it will be half into
120 joules.
120 joules. Right on the next question. A capacitor is fully charged. A capacitor is fully charged. Full stop. Charge on it is 30 coulombs. Charge on it is 30 coulombs. And the PD across the plates is 10 volts. PD across the plates is 10 volts. Full stop. Calculate. Part A. Capacitance of the capacitor. Capacitance of the capacitor. Part B. Energy stored when it is fully charged. Part C. Energy stored when 50% of the charge is discharged. Can you? Done. Done. Guys online, are you done?
Yes, sir.
Right. Guys, the capacitor is fully charged. And when it is fully charged, there's a charge of 30 coulombs on it. And the PD across the plates is 10 volts. So capacitance of the capacitor C equals Q over V, which is 30 over 10, 3 farads. You got this answer? Good. Part B. Energy stored when it is fully charged. Energy stored when it is fully charged. So guys, E equals half VQ. So which is half into B is 10, Q is 30. 10 into 30, which is 150 joules. Sorry. Part C. Energy stored when 50% of the charge is discharged. What is your answer?
75 joules. Wrong.
So very conveniently you decided the answer is 75. Is it? Very good. What is the answer? A bit louder. Can others hear? Anyone who got that answer? The answer is not
Sir, because
75.
when the charge decreases, the voltage also decreases, right? So we have
Correct.
to,
Yeah. Now I
calculate
can
the
look
charge
at,
and then it becomes.
look at this, guys. I will explain this to you in two ways. One is we just spoke to you 5 minutes back. I told you V is proportional to Q. So when the V increases, Q increases, V decreases, Q decreases. So 50% is discharge means the Q becomes half. When the Q becomes half, V also will become half. Okay. So now if you use E equals half VQ, E equals half VQ, it is half into V is, V used to be 10, so V will become 5, Q used to be 30, Q will become 15, which is 37.5 joules. That is one way that you can look at it. Okay. The other way is, now see, or I will give you an alternative method. We know E equals half Q square over C, right? E equals half Q square over C, right? Now, when the capacitor discharges, when the Q reduces or when Q increases, does the capacitance change? No. I clearly told you capacitance is a constant. It doesn't depend on the Q or the V. So if I use half Q square over C, it will be half. Q is what becoming half. So Q used to be 30, right? So Q will become 15 square. Over the C was how much? 3. That 3 will remain the same. So it is 15 square divided by 2 into 3 is 6. 15 square over 6 is how much? 37.5. Okay. Right? Using the, listen, don't try this. Using the same equation, guys, there's another way that I can tell you. Now E equals half Q square over C. Half is a constant, C is a constant. So in this case, what if I tell you E is directly proportional to Q square? Do you understand that? Half is a constant, C is a constant. So E is directly proportional to Q square. So when Q becomes half, E becomes? When Q becomes half, E becomes?
4 times less.
1/4.
1/4.
Because E is proportional to Q square, no? Don't you all understand this proportionalities? Haven't you learned proportionalities for grade 9 maths? When proportionality E is proportional to Q means when Q doubles, E doubles. E is proportional to Q square means when Q doubles, E becomes 4 times. When Q becomes half, E becomes 1/4. Guys, when I'm teaching the grade 9 maths class, I'm serious. Proportionalities chapter, if you want, you can join online and learn it. Because this will help you a lot. Understanding the basics of proportionalities. You're taught O-level maths for a reason, not for fun. Okay, that O-level maths that you have learned, that you can use it until you do your PhD. That is why the students are forced to do O-level maths without a choice. You are given a choice for the other subjects, right? But for O-level maths, whether you do Cambridge or locals or Edexcel, you're not given a choice. You are forced to do maths. That is for a reason. Without O-level maths, you can't do anything in the future. Okay, that is not taught to torture you. So understand this is, if you don't understand the concepts of proportionalities, go through, and if you have younger siblings, go and learn without being shy. It's okay, right? So E is proportional to Q square means when Q becomes half, E becomes 1/4. Understood? So E used to be 150 joules. So without an effort, you can understand that E is becoming 1/4 of 150, which is 37.5. Understood? Right. Right. Guys, right on the next one. Question 3. When a capacitor is fully charged, when a capacitor is fully charged, it has a charge of 40 millicoulombs. On a plate and a PD of 12 volts between the plates. Between the plates. Just a reminder, do we have class tomorrow? Yes, we do have. Okay. Next week we don't have, but tomorrow we have the class. Right. Part A. Calculate the energy stored in the capacitor. Calculate the energy stored in the capacitor when it is fully charged. Full stop. Part B. Calculate the energy stored in it calculate the energy stored in it when it is 30% charged. Right. Can you? That's the answer. Part A, of course, calculate the energy stored in the capacitor when it is fully charged. E equals half VQ, which is half V is 12, Q is 48 into 10 to the power minus 3. Okay. That will be 0.288 joules. Okay. And the part B, calculate the energy stored in it when it is 30% charged, not fully charged. What is your answer? It should be, what is your answer? 0.0? Correct. That's the answer. Right. That means one way that the easiest method I would consider here is realizing that E is proportional to Q square. Correct. If E is proportional to Q square, E is equal to half Q square over C, like how I told you in the previous question. E is proportional to Q square. So the Q is, now we have found the energy stored for a certain Q here. In the next part, the Q that we are referring is 30% of that. Am I right? So the 30% means 0.3. So now the Q is 0.3 of the earlier Q. So that means now the energy stored will be, 0.288 into 0.3 square. This is the easiest way that you can look at the answer. 0.288 into 0.3 square, which is 0.02592 joules. To be precise, this is the exact value. Okay. Another way that you can look at it is, if you are to use the equation and do it, E equals half VQ. E equals half VQ. So it will be E equals half. Earlier V was how much? 12. So now the V will be 12 into 30%. Because when the Q becomes 30%, V also becomes 30%. Into the Q becomes 48 millicoulombs it was. 48 into 10 to the power minus 3 into 30%. Multiply this and check. It's going to be the same answer. So if you understand that it is directly proportional to the square of the Q here. Done. Okay. Is that okay, people online? Any questions? People online, hello, hi. Right, guys, write down the next one, fourth one.
So Anskan, so what's the answer?
0.02592.
Yes, sir.
Right, guys, write down the next question. 1,200 microfarad capacitor. 1,200 microfarad capacitor is connected to a voltage supply. Until fully charged with 10.8 millicoulombs. Full stop. If this capacitor is then disconnected and reconnected across a 10 watt light bulb, how long could it light the bulb for? Give a try. That. What is your answer? Right. The 1200 microfarad capacitor is connected to a voltage supply until fully charged is 10.8 minutes. So basically, you are charging a capacitor and using that capacitor to to supply energy for a 10-watt bulb, right? So the energy stored in this capacitor will be equals half VQ, which is half. No, we don't know the V. We know the C though. So I can use half Q square over C, which is half Q is 10.8, which is 0.0108 square over C is 1200 into 10 to the power minus 6, which will be 0.0486 joules. Okay. Now this you are going and connecting to a 10-watt light bulb. For how long this energy can be given to that one? So for that one, we will use power equals energy over time for the light bulb. Power is 10. Energy is 0.0486 over T. So the T will be 0.00486 seconds. 4.86 into 10 to the power minus 3 seconds. Is that okay? Right. Guys, this, so what do you get to see? If you take this capacitor and go and connect it to 10-watt bulb, what will you get to see? Almost nothing. Why? the time for which this can supply energy to that is not even 1/100th of a second, 0.00486. So if you are so accurate to see if you can see, not even that much, right? So because basically it's a very small capacitor which is used to gives energy to a relatively a much larger bulb. Okay, right. Write down the next subtopic of it. Write down the next subtopic. Bit too early, no? Huh? Tired? More than me? Huh? Write down the next subtopic. We'll do this and get a break. Charging and discharging of capacitors. Charging and discharging of capacitors. Yeah, P equals BI. W power P equals V into I. Ampere into volts. Ampere into volts is equal to 1 watt, correct? Yeah. Yeah. Can. Using Q equals CV. Yeah, using Q equals CV. Let me check it. Right, guys, draw this diagram. So there is a battery, just it's marked 6 volts, and it is connected to a capacitor and another light bulb, which is another lamp, which is connected in parallel to the bulb, to the battery. And there's a two-way switch here. Look at this one. This two-way switch, listen, before you draw it, let me explain this diagram a bit, circuit. So guys, this two-way switch, you can, if you can connect it to A or you can connect it to B. When you connect it to A, what happens? There will be a current coming from this battery and it will charge this capacitor, correct? And when the capacitor is charged, you can move this switch to point B. Then will the capacitor get charged? No, because this connection is not there. Battery and capacitor are not connected. So when you put it to this point, then this capacitor will release the energy stored in it, the charge stored in it. It will supply current to this, the lamp will light up. Great. What if you take this switch and just keep it here? You don't connect it to A or B. It will neither charge nor discharge. So if you put it to A, it will charge. If you put it to B, it will discharge. Can you draw this circuit?
Sir, What's the point of having the capacitor in the circuit? Like, even if we remove that and just keep the switch and directly connect the battery to the lamp, don't we get the same result?
Okay. Now this is, we are doing an experiment to see how the capacitor charges and discharges. Now, in this case, yes, what you are telling is, if your purpose is to supply energy to the lamp, yes, you could have just connected it, but that is not the purpose. Here we want to do an experiment to see how the for a capacitor, how does the charging and discharge work? How does the curve of charging and discharge work? That is what we are going to discuss here. Okay.
Thank you, sir.
Right. And right under that, in the above circuit, when the switch is at A, the capacitor is connected to the battery. The capacitor is connected to the battery and it will get charged. The capacitor is connected to the battery and it will get charged. Full stop. And right below that, when the switch is connected to B, when the switch is connected to B, the capacitor is connected to the lamp and the capacitor will discharge. Capacitor will discharge. Okay. Right. When the switch is connected to B, the capacitor is connected to the lamp and the capacitor will discharge. Okay. Right under that. Separate. The variation of the charge stored in the capacitor with time will be as following. This is, I'm talking about while charging. Okay. So guys, now it will have a graph like this with a decreasing gradient. So yeah, the charge stored on the capacitor will keep increasing, but the gradient, the rate at which the charge is storing will decrease. The rate. So eventually it reaches a certain charge, and after that, how much ever you try to charge it, it will not, the charge will not store because it has reached its capacity. Okay. Draw that graph. Okay. Right. And then guys, right below that. Since the voltage across the plates is proportional to the charge stored. Since the voltage across the plates is proportional to the charge stored. Since the voltage across the plates is proportional to the charge stored. The variation of the PD across plates, the variation of the PD across plates PD across plates with time will be similar to the above variation. Will be similar to the above variation. Okay. So guys, since Q is directly proportional to V, even if you sketch a graph of V versus T, the potential difference across the capacitor versus time, it will also have the same graph, similar to this one. Take down this voltage versus time will also be the same. Okay. And right below that, the charging current with time will vary as following. The charging current will vary with time. The charging current with time will vary as following. So guys, the current which is used to charge the capacitor will decrease like this. Can someone explain me why? Based on what you have written so far, can you explain me why does the charging current decrease? You can use the previous graphs and explain it actually. Now, in this circuit, the current is flowing from the battery to the capacitor.
Something got to do with resistance, right?
That current, no. That charging current is reducing with time. Why? Capacitance is not going to change. Capacitance is a constant.
I mean, when the current is flowing, the wires get heated.
That's not the reason. Let's say the wire is not getting heated at all. I told you using the previous graphs, you can explain it to me.
When charge is increasing, current is
Because current is the rate of flow of charge, right? Now, I told you using the previous graph, you can explain me. Can you see in this graph, what is happening to the gradient? Decreasing. So the gradient of this graph means the rate of flow of charge, which is decreasing, which is current. Understand? When you are charging a capacitor, when you keep the battery on for some time, it won't just keep on charging forever. Its variation is this. Gradient will gradually decrease. So that means the rate at which the charge is accumulated on the capacitor will gradually decrease. The rate at which. Okay, for an example, in simple English, if you want to understand, let's say in the first second it stores, for an example, about 10 millicoulombs of charge. That's second, the next second, it can't store another 10 millicoulombs. It will be less than that. The next 1 second, the charge it can store is even lesser. That is what meant by the rate of storing of charge is reducing here. Okay, so which means the charge which is released from the battery is also reducing every second. Yes or no? So that means the current flow is reducing because of that. Simply because the gradient of this graph is reducing. So that means the current is reducing. So eventually, when this capacitor reaches its maximum charge, okay, will there be a current? No. Current is zero. Why? The battery can't push more charge into the capacitor. Get it? Capacitor has reached its level. So now the battery can't send more charge to the capacitor. So which means what will happen to the current? What will happen to the current? Zero. That's the point. Capacitor has reached its maximum capacity. Understood? So these are interconnected. Don't just memorize, okay? Don't draw diagrams like you're drawing for biology. Okay, these graphs make sense. So understand it and draw. You can make physics easier. Right, guys. There are 2 more graphs to draw. We'll draw that to take a break. When the capacitor is connected to the resistor, when the capacitor is connected to the resistor, when the capacitor is connected to the resistor, it will discharge and the charge and PD will decrease with time. The charge and PD will decrease with time. The variation will be as following. The variation will be as following. Okay, now guys, this way. Now let's say you charge the capacitor fully. After you charge the capacitor fully, now you switch this, put the switch to B. Okay, you put the switch to B. So now the capacitor will release the energy stored in it to light up the bulb. Okay, so what will happen to the charge stored in the capacitor? Will decrease. What will happen to the voltage across the capacitor? Will decrease. Charge is reducing means voltage will reduce. Q is C. Q equals CV. Q is proportional to V. Q is reducing means for a capacitor, definitely the V is reduced. Okay, so eventually Q will become how much? 0. Until it can release all its charge and give it to the bulb, it will release. So the graph of Q versus time now, it will be this one. Okay. Is that clear? Take it up. So the V versus T will be very similar to that because Q and V are proportional. Yeah, guys, draw that and go for a break. See you in 15 minutes.
So could you explain this graph, sir, please?
Yeah, take a break. I'll come back and explain that. Right, guys, get back to work. Okay. Hi. Hello. Yeah, tell me, what do you want to tell? Yeah, do you have to tell anything? Yeah, you are going to tell something. Tell. No, it's okay, don't be shy. Tell. Who is asking? He's asking you. Why can't I? Right. Right. Guys, let me repeat it. So this is how, while the capacitor is discharging, when the capacitor is connected to the resistor, the capacitor will give out its charge stored, the energy stored. So when it is giving the charge stored in it out, so the charge stored in it will reduce. So Q will reduce. So the Q versus time will decrease. Q will decrease with time. So it will be a graph like this. Okay, so the rate at which Q is decreasing will also decrease. So it will be a graph which is with a decreasing gradient with time. So Q versus T graph and V versus T graph will be the same thing because V is proportional to Q. So how Q varies will be the same way that V will be varying. Okay, right. There's one more. Continue. Right below that. The variation of the discharging current. The variation of the discharging current. The variation of discharging current with time. With time will be as following. Okay, right. Then right below that. When the capacitor is discharging through the resistor, when the capacitor is discharging through the resistor, comma, the charge stored in the capacitor will have an exponential decay. The charge stored in the capacitor will have an exponential decay.
So what do you mean by through the resistor, sir? So instead of a bulb, there's resistor.
Yeah, bulb is a resistor. No? Bulb head. That is what meant. Okay, bulb. Okay, right, fine. So guys, now I'm going to give you an equation. So right below that, it is given by an exponential decay. It is given by Q equals Q naught e to the power minus T over RC. Out of you all, who is not doing A level maths? Put your hands up. Not doing maths?
Me, sir.
Okay. Q equals Q naught e to the power minus T over RC. Let's define the terms. Q naught is initial charge stored in the capacitor. Initial charge stored in the capacitor. C is capacitance of the capacitor. Capacitance of the capacitor. R is resistance of the resistor. T is time. Q, charge stored at time t.
So earlier page.
Q is charge stored at time t. And the right below, RC product is known as the time constant, R into C. R into C is known as the time constant. Okay. Those who are not doing maths, have you heard of this number E? Have you heard of E? What is the value of E? Use the calendar and tell me what is the value of E. Two point? Yeah. Do you all know where is E in the cap? There are two places you will find the E. Okay. One is just to get the value of E. The other one is to get E to the power. Have you spotted the 2 points in the cap? Correct. So E is just a number. Just a number. Like pi is a number, 3.14, blah, blah, blah. E is another number. So there's no point I'm talking to you about the history of E. No. There is a history behind E. There's a definition behind E. So for math students, yes, it's okay for you to know. But physics students, I mean, if you're not doing physics maths, totally useless knowing what is E and why is this E is important. How did this E magical number come? What is the importance of E? But it's a very important number. No point for you, I'm talking about it. So I will just leave it there. E is just a number. The number is there, 2.7, blah, blah, blah. You can use the calendar and get it. Right. So that's about E for you. So we'll see how it is going to be useful for us. So guys, if you have a capacitor which is initially having a charge of Q naught, and when you connect it to and if it is having a capacitance C, and if you connect it across a resistor with resistance R, the charge stored in the capacitor will reduce with time. Correct? So if you want to find the charge stored in the capacitor after 1 second or 2 seconds or whatever, we can use this equation and find what is the charge remaining in the capacitor. Understood? Okay. Right. Similarly, now Q equals Q naught e to the power minus T over RC. We have accepted this equation. Now by using Q equals CV, let's say when the charge listen to me carefully, when the charge comes down to Q, the voltage has come down to V. And let me also say that when initially the charge was Q naught, initially the voltage was V naught, then I can tell you these two equations, Q equals CV and Q naught equals CV naught. Agree? Then by using that into this, Q equals CV. So the Q, I will write it as Q naught e to the power minus T over RC into C into V, right? So the Q naught, I can write it as C into V naught. Q naught is C into V naught. Then it will become C into V naught into e to the power minus T over RC is equal to CV. Then the C's on either sides will cancel off, and you will get a nice equation for V, which is V equals V naught e to the power minus T over RC. Q equals Q naught e to the power minus T over RC. V equals V naught e to the power minus T over RC. Understood? Take it out. Right? So guys, V is the voltage after time t, and V naught is the initial voltage. And similarly, we can come up with an equation for the current flowing as well. Look at this one. V naught is equal to initial current I naught into R. And after the voltage has become V, let's say the current is I, V equals I into R. V naught is I naught into R. By using those, in this V equals V naught e to the power minus T over RC. If I replace the V with IR and V naught with I naught R, again on either sides, the R's will cancel off. And you will get this equation, I equals I naught e to the power minus T over RC. So guys, it's easy for you to remember if you just remember one equation. Q equals Q naught e to the power minus T over RC. V equals V naught e to the power minus T over RC. I equals I naught e to the power minus T over RC. So all three graphs had an exponential decay graph. Q versus T, V versus T, I versus T. All were exponential decay graphs. So the equation of those graphs is what given by these three equations. Take down that as well. Guys, before you come tomorrow, go through the notes that we did today. So tomorrow the questions will be based on this.
So why aren't you having classes towards the end of the month?
It's actually Platinum will be closed for the last, it's holidays here. The last 10 days of August. Right? Let's write down a question. A 0.03 farad capacitor. A 0.03 farad capacitor is fully charged. By a 12-volt supply. A 0.03 farad capacitor is fully charged by a 12-volt supply and is then connected to discharge through a 900 ohm resistor. Of 0.03 farad capacitor is fully charged by a 12-volt supply and is then connected to discharge through a 900 ohm resistor. Through a 900 ohm resistor. Full stop. What is the discharge current after 20 seconds? What is the discharge current after 20 seconds? Okay.
Sir, can
Right,
you
yes.
decrease so I can see the full question? I didn't write the full question.
Let's read the question. I will do it. First question, I will do it.
So can you give 5 minutes to try and do it?
Since it is the first one, I will do it. I will give you another question after this. Okay. Right, because I can give you a few methods, different methods to do it for you to understand the equations. Look at this. So guys, there is this capacitor with a capacitance of 0.03 farads. And you have connected it to a battery which has a voltage of 12 volts. And then it is connected to discharge through a resistor. The resistor has a resistance of 900 ohms. So the question is, while it is discharging, when it is discharging, what is the discharge current after 20 seconds? After 20 seconds, what is the discharge current? Listen, just look at the board. Just look at the screen. One method is, I will do this. Guys, one method is, I will take V equals V naught e to the power minus T over RC. Okay. I will take V equals V naught e to the power minus T over RC. I will first find what is the voltage after 20 seconds. Okay. So voltage after 20 seconds will be V equals, the initial voltage across the capacitor is 12. Agree? Because it was charged by a battery of 12 volts. So when you fully charge a capacitor with a battery of 12 volts, once it is fully charged, the capacitor's voltage will also be 12 volts. Agree? So now initial voltage of the capacitor is 12 volts, e to the power minus 20 over RC. R is 900 into C is 0.03. So 12 into e to the minus 20 over 900 into 0.03. I'm getting 5.721. Correct me if I'm wrong. 5.721. This is the voltage across the capacitor after 20 seconds. Now, so this will be the voltage across the resistor as well, because the capacitor and resistor will have the same voltage. Okay. So now if I use V equals IR for the resistor, V is 5.721. This is the voltage across the resistor. I is what I want to find. The R is 900. So this will give me the current 5.721 that divided by 900, which is 6.36 into 10 to the power minus 3 amperes. That is one way of doing it. Yeah. Because it was, the capacitor was charged by a supply battery which has a voltage of 12 volts. You have a battery, you connect it across a capacitor, and you fully charge it. This battery is 12 volts. So when this capacitor is charged, and when it is fully charged, the capacitor will have a voltage of 12 volts. So now that capacitor is what you are going and connecting it to a resistor. So initially, what is the voltage of the capacitor then? 12 volts. That is the maximum capacitor can take. So anyway, with time, its voltage will decrease. Understood? Any questions? This is one way of doing it. Okay. I'll give you another method. Are you okay with this? Any questions? Right. The method 2, look at this. I will use V equals IR to find the initial current through the resistor. So initial voltage is 12. I into the initial resistance is 900. Resistance of the resistor is 900. V is 12. So this gives me the initial current, which is 12 over 900. 12 over 900 is, I'll take it as 1 over 75, say, amperes. This is the initial current. We want the current when? After 20 seconds. So now I can use this equation, I equals I naught e to the power minus t over RC. I is what I want. I naught is 1 over 75 into e to the power minus 20 over RC, 900 into C is 0.03. Okay, check this and see. .36 into 10 to the power minus 3 should be the same answer. Any questions? Right, guys, write on the next question. A capacitor.
So I'm going to write the answers.
What? Answers of what?
These answers. You didn't give us time to write.
Oh, really? Please take it down.
Can you show the method once please?
Did you all write it?
So could you show the screen on this?
Okay, right. Let's write on the next one. Question 2. A capacitor has a charge of 200 millicoulombs. A capacitor has a charge of 200 millicoulombs. Stored in it. Full stop. It has a capacitance of 20 millifarads. It has a capacitance of 20 millifarads. And connected across a 100 ohm resistor. Connected across a 100 ohm resistor. Full stop. Calculate part A. Initial voltage across the capacitor. Part B. Voltage across the capacitor after 1.5 seconds. Voltage across the capacitor after 1.5 seconds. Part C. Charge stored in the capacitor after 1.8 seconds. Charge stored in the capacitor after 1.8 seconds. Part D. Part D. Total charge passed through the resistor in the first 1.8 seconds. Total charge passed through the resistor in the first 1.8 seconds. Part E. Initial current passing through the resistor. Initial current passing through the resistor. And finally, the part F. Current through the resistor after 2.1 seconds. Okay, guys, that's it for the day. Complete this question for homework. See you tomorrow.
So can you show all the questions, the parts? You went too fast.
Okay, then see you in another 20 hours and 45 minutes. Okay. Huh? See you in 20 hours and 45 minutes, I said. Tomorrow at 9 a.m. When did we have the class at 10 on Saturday? Today is Saturday.
Thank you, sir. Bye. God bless.
See you at 9, guys. Bye. Complete this and come and go through the
So can
notes
go
and
to next page, sir, please.
what did you say? Yeah, eventually it will come. Wait. Give some time. Give some time.
9 is too early.
9 is too early.
Actually, it's too early.
Okay, what is a good time then? 11. Okay. 11 is a good time. So 11 is not too early.
It's not too early. It's not too late.
11 is not too early. 10:55.
That's too early.
10:55 is too early. 11 is not too early. Done, Avila. Bye, people. See you. Take care. And if
So
you haven't,
Ansman, sir, send me the F sir, in the group. Sir, I'm just almost done, sir.
what in the group? What?
F question F.
Yeah. Those who didn't inform me the results. The results. Okay. Bye. See you. Take care. We didn't do it.
Sir, can you go to D, sir, for 1 second, sir, please?
Oh my God. It's taking me from A to C to D to F to B. Okay.
Sir, I said D, sir, not B. Okay, sir. Thank you, sir.
You're welcome. Thank you.